Hi, fourth graders. We are ready for our math lesson today. We'll have 2 pages of notes again, and we are on Module 4, Lesson 12. So we made a big jump. We're going to skip some, and we are focusing on lines of symmetry today. So go ahead and write your table of contents, and then we'll skip to our note page today, and we'll be on this page first. And you can see our objective says, I can recognize and draw lines of symmetry for 2-dimensional figures. Okay. Now, I want us to imagine first that we have this square shape here. And if I wanted to fold this square in half so that 2 sides are matching exactly right, what are some ways that I could fold this shape? Well, I think right away you know that we could fold it right here in half. So I'm going to go ahead and draw a line this way in half. I can also go in half this way. Now I want you to think, are there any other ways that I could fold this square where it would be perfectly equal? Well, I know some of you are used to making origami, and when you take a square and you fold it in half diagonally, you get a triangle. And so I know that I can fold it both ways diagonally. Every time I pick one of these lines to fold on, each side matches up just perfectly and they are equal. Okay? Now I want us to do the same thing with this rectangle. How could I fold it so that it looks exactly equal on when it's folded in half? So I know that if I folded it here, that wouldn't be equal. But if I came down here and I folded it in half here, now I'm doing my best to show where I think half is. Okay, and I think I can fold it this way. I can do hamburger, and now I can do it hot dog style. That those would be equal. But if I tried to take this rectangle and I tried to fold it from diagonal, so corner to corner like I did over here on the square, I know that it would not line up to be equal. Okay? So what we just did here in these 2 shapes is we found the lines of symmetry. So I'm up here in my notes. So a line of symmetry is a line on which you can fold an image to have both sides equal. That means it has to match exactly the same. And so when I look at this square and I want to count how many lines of symmetry this square has, I'm going to count how many lines I drew. So I started and I went like this, 1, 2, and then I went diagonally, 3, 4. So my square has 4 lines of symmetry. 4 different ways that I can fold a square and have it be equal on both sides. My rectangle I see has 1, I drew it hamburger style, 2, hot dog style. It has 2 lines, oopsies, of symmetry. So if I look at this statement, it says the something has more lines of symmetry. So which one of these 2 shapes had more lines of symmetry? And you were right, it's the square. This is because what's different about a square than a rectangle? The reason I could fold it diagonally is because all of the sides are equal. So this is because all sides are equal. That is why I'm able to fold it diagonally on a square and not the rectangle. So we practiced making some lines of symmetry. Now I have another shape for you. Okay, I have this circle. So I want you to think about if I had a circle cut out of paper and I could fold it in half, how many ways could I fold it? So I'm going to get started. I'm going to go in half. And again, we're just kind of doing our best to show where half would be. That would be exactly equal. Here would be exactly equal. Mine is kind of off center, so sorry. I think I could go this way. I think I could go this way. Notice they're all meeting at the center point. Fourth graders, I feel like I could keep going and doing this for a very long time. And if you feel like that, you are correct. And in fact, a circle has an infinite lines of symmetry. There is no end to the amount of times that you could fold a circle and it would be perfectly equal on both halves. So a circle has this special characteristic, a special trait that allows it to have an infinite number of lines of symmetry. Pretty cool about that circle. Go ahead and flip to that second page for me. Now we're going to get some practice in looking at some other shapes and pictures, because even in an image I might be asked, is there a line of symmetry? So the directions for this section say circle the figures that have a correct line of symmetry drawn. So if I look at letter A and I see this shape and I see this dotted line, that dotted line is telling me this is where that line of symmetry would be. If I folded against this line, they would line up perfectly equal. Well, if I imagine flipping this over, it lines up just right, so I'm going to circle it because that line of symmetry is correct. Now if I look at letter B in this pentagon, if I were to put a crease and fold this top half down on that line, are they going to be the same? If you say no, you are correct. So I'm going to leave that one. I'm just going to write a no to remind me. That is not correct. Now if I look at letter C and I see this heart, if I fold that heart in half, I know that that would be equal and perfect. So that is the correct line of symmetry. And then looking over here at letter D, if I fold it on that line, I can tell that that's not going to be equal and symmetrical. So that is not the correct line of symmetry. Now we've got some more practice. I have some extra shapes over here where we're going to practice creating the lines of symmetry. And I'm going to show you a trick that will help, especially when we don't have the paper in our hands to fold. So I'm going to look at this pentagon, and if I look at it like this, and I'm going to draw a line of symmetry right down the middle. Because when I fold this half over, it's going to line up just perfectly. Now right now it looks like I don't think there's any other way. I can't go the top and go hamburger style down. That wouldn't work. But watch what I'm going to do. I'm going to rotate my paper just a little bit. And now I can see, oh, I see another line of symmetry just like before. If I were to fold it here, it's going to be equal as well. Oh, I'm going to rotate it again. If I rotate it again, and now I have a new point at the top. Let me get it so it looks like a new point for you. A new point is at the top of my pentagon. I can go from top to bottom just like I did every time. I'm going to check and see. Oh, I've got another one that I see that's not used yet. Here's another point at the top of my pentagon right here. So I'm going to go from the top to the bottom right in the middle, and that's another line of symmetry. Oh my goodness, look at that. Look how helpful it is when I am rotating my paper to see there are some more lines of symmetry than I originally thought. There's all of my lines. I went from the center point all the way around as I rotated my shape. So now I need to count, well, how many lines of symmetry do I really have? So I went from 1, 2, I'm counting the points that I went to, 3, 4, 5. There are 5 lines of symmetry on that pentagon. That one was a little bit deceiving when we first started. So using that trick of turning and spinning your paper is extra helpful. Now let's look at this shape. Kind of looks a little bit like a square with some cut off corners. So I'm going to think about if I were to fold this in any direction, which way can I do it? Now if I folded it in half, if I drew a line vertically and I tried to fold it hot dog style, well, I can already tell that those corners are going to be a problem. Those corners will not line up perfectly. And the same thing if I tried to fold it down this way, hamburger style. But I wonder if I could do it this way. Go diagonally, and I could fold it just like so on both those lines, and those would be equal. So now I have 2 lines of symmetry for that shape. All right, let's check out this arrow. Ooh, how could I draw lines of symmetry for this arrow shape? Well, I know that I could fold it right down the middle this way, and those 2 sides would be equal. I could fold it down the middle this way, and those 2 halves would be equal. I'm afraid if I tried any other direction, nothing else would match up. So again, I have 2 lines of symmetry. I have one last shape. I have this crescent shape. How could I fold it so that it's perfectly equal? If you said right down the middle this way, you are correct. And friends, that is the only line of symmetry on this crescent shape. One line. Nice job of identifying those lines. Here's our last job today. So this direction says, using one side of the shape and line of symmetry, draw the rest of this shape. Now I know that your notes didn't quite print those grid lines, and I apologize, 4th graders, but you can see on my paper here that there are some grid lines. And so when I see that there's these grid lines, I'm going to count and use those as a way to know that it's going to be exactly perfect. So I'm going to continue on these horizontal lines first, because that's part of my shape that's still touching. This is the line of symmetry that I'm going to use, that's half. So on this half of my line, I have 1, 2 squares for my top line. So I'm going to go 1, 2 squares. Now I'm going to look at this bottom line, and I'm going to see how many squares I went. I went 1, 2, 3, 4 full squares, 5. 1, 2, 3, 4, 5. All the way to your edge. Now I'm not done yet because it's still not symmetrical. I need to close it off. Now this one's a little bit tricky because this line is a diagonal. And so I'm going to look, and coming off of the end of my shape, I have 1 square diagonal. So I'm going to go 1 diagonal square. I have another diagonal and 1 more. So I had 2 more diagonal in those squares. And now my shape is perfectly symmetrical or equal on both sides. Very nice job today identifying and drawing your lines of symmetry. Good work.